Welcome to the class of structural analysis. In the previous class, we solved how to solve degree of kinematic indeterminacy in case of fixed, in case of hinge, if the roller value comes. Okay, now today we will solve the degree of degree of indeterminacy and static indeterminacy in case of beam, in case of truss, and in case of portal frame. Okay, so take a problem. At first take a beam. Okay, so this is your question 1. This is a hinge support. Okay, and we take a beam that this is fixed support, and here there is a internal hinge. Okay, you have to calculate ds and dk. This is your problem. So how you can solve this type of problem? It is very much easy. Just you have to follow previous day's formula. Okay, I can show you now. First, ds dk. In this portion we will calculate our ds value, and in this portion we calculate our dk value. Okay, we all know that our ds value is dse plus dsi. That means static indeterminacy is equal to, this is the summation of static indeterminacy for external plus internal static indeterminacy. Okay, in case of beam, this is a beam problem. So in case of beam, our external indeterminacy is r minus 3. So write it r minus 3. Okay, now you can see this is an internal hinge. So in case of internal hinge, there is m dash minus 1. What is m dash? M dash is your number of member connecting to the internal hinge. So here two member is connecting this internal hinge. That means this internal hinge is connected to member. So your m dash value will be 2. Now what is your dsi value? Take a look. In case of beam, for dsi this is 0. So dsi is 0. Okay, now just put these values of r and m dash. You can clearly solve this ds value. What is your r value? R means here how much? 1, 2 equilibrium forces, and here 1, 2, 3. Okay, what is your r? R is nothing but number of unknown reaction component. Okay, so here unknown reaction component how much? 2, and here is 3. Okay, here unknown component is vertical and horizontal, and here is vertical, horizontal as well as moment. Okay, so your r value is 5 minus 3 is m dash is 2 minus 1 plus 0. So 5 minus 3 is 2. 2 minus this 1, that means 1. So your ds value come 1. That means in this problem your static indeterminacy is 1. Now move on to kinematic indeterminacy. What is your kinematic indeterminacy? Kinematic indeterminacy is nothing but you can use this formula, but as I told earlier, we will not use these two formula for case of beam and frame. We also use this formula 2j minus r in case of truss only. In case of determining the kinematic indeterminacy, in case of beam and frame, we use degree of freedom funda. So from this problem we can say this is a hinge, so 1, as I told earlier, in case of hinge there is 1 degree of freedom, okay, 1. This is how much, what, this is the internal hinge, okay. So in case of internal hinge, 1, 2, 3, okay, in this member, okay. And here nothing. So 1, 2, 3, 4. You can see in case of fixed is decay is 0. There is nothing, degree of freedom there. So your decay value is come 1, 2, 3, 4. This problem is complete. Look how easily you can solve degree of static and degree of kinematic indeterminacy in case of beam structure. Now take another beam problem. Take this is a fixed beam, okay. Two end of this beam is fixed. This is called fixed beam, and in this fixed beam, for the sake of hardness of the problem, I give two internal hinge there, okay. Two internal hinge is there, so you have to calculate your ds and decay value. Very much simple. First step, you divide ds and decay in two portions. What is your ds value? Ds value is dse plus dsi, okay. What is your ds value? Same, r minus 3 minus, now look here two internal hinges there, so for two internal hinge m dash minus 1 minus of m dash minus 1, and for dsi is 0, as in case of beam your internal static indeterminacy is always 0. This is a hard and fast rule. So what is your r value? Here 1, 2, 3, and here 1, 2, 3, so that means 6 minus 3 minus, this is for this internal hinge, so m dash value is 1 and 2, so 2 minus 1 minus this value is for this internal hinge, okay. So 1, 2, so 2 minus 1 plus 0, so how much? 6 minus 3 is 3, 3 minus 1 minus 1, so 3 minus 1 minus 1 plus 0, so 1. So here your ds value is 1 also, okay. Now move to decay value. Decay value is, as we solve this for degree of freedom, here degree of freedom how much? 0. Here degree of freedom 1, 2, 3, and here also 1, 2, 3, okay. So 3, 3, 6, so decay value is 6 for this figure. Done. So you can see how easily we can solve the beam problem for determining ds and dk, that is degree of static indeterminacy and degree of kinematic indeterminacy. Okay, now move on to truss portion. So take a truss. I am taking a truss like this. This is connected hinge. This is also a hinge. I am taking a simple truss. Okay. Okay, so this is a truss. Name it this point A. This is B, A, B, C, D, E, F. Okay, and don't misguide this point. This is not an internal hinge. This is a member and this is another member. Two members are not connected. That means this type. Okay, this type. This is one member and this is two members. Don't misguide by 1, 2, 3, 4. That is 4 member, not that. This is one. This is one. Okay. So you have to calculate ds and dk. You have to calculate your ds and dk. Same, you solve ds first and then dk. Okay. Here same rules applied. ds is equal to dse plus dsi. Okay. In case of dse for truss, how much? dse is r minus 3. Same. So r minus 3. Okay. Plus dsi. Now look, in case of dsi for truss, the formula is m minus 2j minus 3. So at first write it down, m minus 2j minus 3. Okay. Now what is r? R is here 2 and here 2. Nothing joint is there. So 4 minus 3. 2 plus 2, 4. 4 minus 3 plus m. What is your m value? M value is nothing but your number of member. What is number of member? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 member is there. 10 minus j. What is j? J is number of joint. Number of joint 1, 2, 3, 4, 5, 6. Okay. This is not a joint. I told earlier, this is not a joint. This is two independent member. That two member are not connected. So 2 into number of joint, how much? 6. 6. Okay. Minus 3. So 4 minus 3 is 1 plus 6 to 12. 12 minus 3, 9. 10 minus 9, 1. So your ds is 2. Done. Your static indeterminacy is calculated. Now in case of degree of kinematic indeterminacy, dk is equal to, look the formula. In case of truss, for dk, take this formula, 2j minus r. Okay. So dk is equal to 2j minus r. Here j value how much? 6. So 2 into 6 minus r. R is nothing but, what is r? I told earlier in the previous class, r is number of reaction present in the diagram.
So number of present reaction in the diagram is 2. You have 2, that means 4. So 12 minus 4, that means the value comes 8. So in this trust problem, your degree of kinematic indeterminacy is 8. Okay. So trust problem is also solved. Now take another problem. This is a closed loop problem, right? Closed loop problem. What is closed loop? Take a look. This is a structure. You have to calculate ds and dk from this. This is question number 3, and this is question number 4. Acha. ds and dk you have to calculate. First of all, ds is dse plus dsi. Okay, and ds. Okay, so ds is dse plus dsi. So dse is r minus 3 plus dsi. You can see, actually this is a frame problem. Okay, frame problem, closed loop. So for frame, dsi is 3 into c. C is number of closed loop. So 3 into C. R minus 3, what is your R value? This is a fixed support. So R value is 3 minus 3 plus into, now C is number of closed loop. So here one closed loop is there. So C value is 1. So your value come 3. That means your ds is 3. Now solve dk. Dk is very much simple. We don't use this formula for frame. We use degree of freedom. Degree of freedom. This portion, 1 degree of freedom is there. In this portion, 1 degree of freedom is there, and this one also. Here we don't use this because in this direction we also give a degree of freedom. Here 1 and here 1. Here 1 only, as this is also given in this direction, and in this point 1, 2 and 3. This is no degree of freedom, as there is no degree of freedom will be there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So your decay will be 9. Okay, so this closed loop of portal frame can be also can be calculated by this. Now take a typical portal frame structure. This is question 4. This was question 4. So this is question 5, right? Question 5. So take a typical portal frame. I am taking a portal frame. Okay, this is fixed support, and this is, take this as a hinge support, and some other member. This is a roll-out support, and 1, 2, 3, and give it an internal hinge. Okay, you have to calculate ds and dk. Now this is a portal frame structure. So for determining ds, you have to know what is dse
and what is dsi. In case of dse, from the previous class for portal frame, dse is r minus 3. R minus 3, what R minus 3, and this is the internal hinge, so m dash minus 1 plus dsi. In case of dsi, this is dsi for frame, this is 3 into c for closed loop, so 3 into c. R minus 3, what is your R value? This is 3, this is 1, 3 1 4 plus 2 6 minus 3 m dash. Here 1 connecting member, 2 connecting member, 3 connecting member, that means 3 minus 1 plus 3 into c. This is the number of closed loop. So here you can see number of closed loops, how much. This is a closed loop, 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 and this is a closed loop also. So 1 2 3 4 5 6. So number of closed loop is 6. So 6 minus 3 is 3, 3 minus 2 1 plus 63. 6 into 3 is 18, that means 19. So here your degree of static indeterminacy is 19. And for decay, for the calculation of decay, you have to take degree of freedom. Here, starting from this, 1 2 1 2 1 2 1 2 and for this also. Here 1 1 1 1. From this nothing will be happen because this is a fixed support. For the internal hinge, this portion 1 2 and 3, and this is 1. For this case 1, for this case 1, and this is for roller, so this is 1 also. So how much? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So your decay value is 20. So now you can solve portal frame, beam and truss problem for determining degree of indeterminacy, degree of static indeterminacy as well as degree of kinematic indeterminacy. Okay, that's all for today now. Thank you.